Hello everyone. So this is a question from JEE Advanced 2026 paper 1. So you can pause your screen and go through the question. So the chapters involved is thermodynamics. Okay. So initially we have a container and we have zero point 0.5 mole of an ideal gas and the internal pressure is 2 bar. Okay. And everything that we are doing is at a constant temperature of 600 Kelvin. So temperature is constant. So isothermal conditions. Okay. So then we compress this in two steps. Okay. In the first step, it is against a constant external pressure of P bar. Against a constant external pressure of P bar, and the value of P ranges from 2 to 8. Okay. So now what we are doing is in the original ideal gas, we are applying constant pressure P. So we keep applying this till the internal pressure becomes P. Okay. Initially the internal pressure was 2 bar, then we apply external pressure P till the internal pressure becomes P from 2 bar. Okay. In the second step, so the compression is against a constant external pressure of 8 bar. Okay. So compression is against a constant external pressure of 8 bar. Okay. So now the same ideal gas, we apply a external pressure of 8 bar and we keep applying this till the internal pressure P internal becomes 8. Okay, so it was P here, then we apply 8 bar pressure so that the internal pressure becomes 8 from P. Okay, so in the first step our initial pressure was 2 bar, then finally it became P. So I will write this down. P initial was 2, P final became P. In our second step, P initial was P and P final is 8. Okay. So most important observation is that compression is done in just two steps. This is the first step, this is the second step. Okay. And also P external is maintained constant in each step. Here it is P and here it is 8 bar. So therefore it's an example of irreversible isothermal compression. Okay. Both of these are example of irreversible isothermal compression. Okay. So therefore we can write work as minus P external into delta V. Okay. And this is true for compression as well as expansion. Okay. So I can write minus P external into V2 minus V1, where V2 is the final volume, V1 is the initial volume. Okay. So let's say work done on gas in first step is W1 and volume of ideal gas is nRT by P. So this is from the ideal gas equation. Okay. So I can write in the first step, the external pressure is P. So I can write minus P into V2. Final volume is going to be nRT by the final pressure, and the final pressure in the first step is P. So nRT by P minus initial volume will be nRT by initial pressure. Initial pressure in the first step is 2. So nRT by, okay. So this will come out to be minus nRT plus P into nRT by 2. Okay. Let's say the work done on the gas in the second compression or in the second step is W2. So therefore W2 will be equal to the external pressure in the second step is 8 bar. So minus 8 into nRT by final pressure is 8. So nRT by 8 minus nRT divided by the initial pressure, which is P. So W2 will be equal to minus nRT plus 8 nRT by P. Okay, so the total work done W will be equal to W1 plus W2. That is, W will be equal to minus nRT plus P nRT by 2 minus nRT plus 8 nRT by P. Okay, so it will be minus 2 nRT plus P nRT by 2 plus 8 nRT by P. Okay, so W will be equal to, taking nRT common, P by 2 plus 8 by P minus 2. Okay, to find the minimum value of magnitude of work done, we have to know the minimum value of P by 2 plus 8 by P. That is this. Okay, for that we can use the arithmetic mean geometric mean inequality. It is AM GM inequality, which states that for any positive numbers A and B, for positive numbers A and B, in our case A is P by 2 and B is 8 by P. Okay, the arithmetic mean is always greater than or equal to the geometric mean. That is, AM is always greater than or equal to the geometric mean. So the arithmetic mean of A and B is A plus B by 2, which will be greater than the geometric mean of A and B is root of AB. Okay, so in our case A and B are P by 2 and 8 by P. So therefore P by 2 plus 8 by P divided by 2 will be always greater than or equal to root of P by 2 into 8 by P. So this gets cancelled. So 2 fours are 8. So this is basically 2. So therefore I can write P by 2 plus 8 by P is greater than or equal to 4, right? So therefore the minimum value of P by 2 plus 8 by P is 4. Okay, so minimum value of P by 2 plus 8 by P is equal to 4, and that happens when, you know, this is equal to 4. So let's take LCM. 2p, p square plus 16 is equal to 4, and so p square minus 8p plus 16 is equal to 0. So I can write this as p minus 4 whole square is equal to 0. So therefore p will be equal to 4. Okay, so therefore the minimum value of p by 2 plus 8 by p is 4 when p is equal to 4. Okay, and in the question the range of p is given to us as p should be greater than 2 and it should be less than 8. So therefore p is equal to 4 is an acceptable value. Okay, so therefore the minimum value of the magnitude of work done will be equal to, so the minimum value of p by 2 plus 8 by 2 is 4. So therefore W will be equal to nRT into 4 minus 2. So this is 2 times nRT. Okay, so therefore minimum magnitude of work done will be equal to 2 into number of moles is 0.5 into R into 600 Kelvin is the temperature. So this comes out to be 600 R joules. Okay, so therefore the final answer, that is the minimum value of magnitude of work done, is 600 R joules. Okay, thank you.